All right, so we're going to look at systems of equations. So we'll see what we mean by that, and we're going to solve, in a sense, lines intersecting with each other, trying to figure out how and where that happens. All right, so let's get started. So if you're watching this video, you'll just ignore this part. In class, that's what we're going to go through. Just practicing drawing out some lines. All right, let's go through this example. So we want to solve the following systems by graphing. So when we say to solve a system of equations, what we mean is we want to find the point of intersection. And the reason why that's going to happen is if you have multiple lines, I'm just going to do a very quick sketch here. You could have a line going like that, a line going like that. They will meet at some point. That's what we're looking for. Okay, so we have the equation of the line y equals 2x minus 2 and x minus y plus 1. Okay, so let's graph these out. So for the first line, we can see that it's in slope y-intercept form. So the number 2, that's the slope, and the negative 2, that's the y-intercept. And if we have something in slope y-intercept form, what we can remember is that you can graph this out by first plotting out your y-intercept. So I'll plot that down. And then use the slope. In this case, 2 means for every unit you go to the right one, you go up 2. And that's your next point. And I'll do this a few times over just to get a number of points on this graph so you can see that pattern going upwards, and you can even go backwards. So if you go back 1 unit, you go down 2. All right, and then we want to draw a line because this is an equation of a line, so we can draw the line through these points and make use of a ruler to get it nice and straight. Okay, and I will also label this. So I will call this y equal to 2x minus 2 up here. All right, let's take a look at the second equation. So we have x minus y plus 1. There's a couple of ways you could go through this. You could find the intercepts, graph it that way. What I'm going to do is I'm just going to rearrange this equation and get it into slope y-intercept form and plot it in a similar manner we just did this first one. Okay, so let's take a look at getting this into slope y-intercept form. So we want to get y by itself. Right now you have a minus y, so we want to move that over to the right-hand side of the equation. If we're moving it over, we have to do the opposite operation, so we need to turn it into a plus y. So you're going to have x plus 1 equal to 0 plus y, which is just y. Or just turning that equation around, that's the same as saying y is equal to x plus 1. Now we have it in slope y-intercept form, so we can identify the slope. If there's no number in front, remember that just means the slope is 1. And the y-intercept at the end, b, is equal to 1 as well. All right, now let's graph this out. So plot the point 1. And then the slope tells us that for every 1 we go across, we go up 1. So you're basically just going to the top right corner of each grid. Then go along and plot that out. And I'm also going to go backwards, just following that same pattern. And again, make it a nice straight line. And by plotting more points, it'll make it a lot easier when you use your ruler to get it very nice and straight. So let's try that again, just to get it a little straighter with the ruler. Okay, there we go. So there we have our line. And I'll label this, so x minus y plus 1 equal to 0. All right. And what do we notice? Well, if you look at your two lines, they're going to meet up right here. That's the point of intersection. And we can actually figure out the coordinates. So the coordinates of that, well, where is that from the origin? It's 1, 2, 3 units to the right. And you go up 1, 2, 3, 4 units upwards. So the point of intersection is 3, 4. And that's what we mean when we want to solve a system of equations. Okay, let's continue. And let's take a look at this second one. So in the second one, both our lines are in slope-y-intercept form, so that'll help just speed things up. But let's begin like we did the first one. So graph the one line using the slope and the y-intercept. So we're going to go to 2 on the y-axis and then use the slope. This time the slope is a fraction, so this just means for every 1 we go up, so that's the rise, the run is 2. So we go across 2 and up 1, or you could think of it up 1, across 2. So that would be the next point. And you can just do that a few times, just again to get a very good feel of what this line should look like, because we want to be as accurate as possible. Then connect it with a ruler. All right. There we go. We have our line, and I will also label it. So y is equal to 1/2 x plus 2. Let's draw out the second line. So the second line, we'll just go for purple. Or I don't know what's going on there. We'll do that. Okay. Again, the slope is 1/2. And the y-intercept is -3 this time. So again, let's find our y-intercept. Go down to -3. And then for every 1 you go up, you go across 2. Again, rise over run. And we can keep this up. Plot a few points, and you can go backwards as well. Again, you'll notice a pattern. Then connect it with a nice ruler. All right, and there we go. We've plotted that line, so let's label it. So y is equal to 1/2 x minus 3. And if you look at these two lines, you're going to see that, oh, they're not crossing. And in fact, if you were to continue these graphs like towards infinity, they will never cross. So the lines never cross. So no solution. And the reason being is that, well, if we go back to the slopes of these lines, the slope of the one is 1/2, the slope of the other is 1/2, and if we think back to earlier equations with lines that we'd looked at, when two lines have the same slope, that means they're parallel. And since they don't start at the same spot, they'll just stay apart forever and ever. So not every system of equations is going to have a solution. There can be cases like this where you don't have a solution. Okay. And what we're going to do is we're just going to change this question. We're going to change it back to A. Show your algebraically your answer to B as the solution. Well, it should be A. And so we will just quickly fix that. All right, so there we've got the equations from A. So if we want to show that the solution 3, 4 is the actual solution algebraically, well, we know 3, 4 just means that, coordinate-wise, that means you have an x value of 3 and a y value of 4. So what you can do is in each equation, and that's why we split this in half, we'll just substitute in the values for x and y and just double check, does that equation remain true? So for example, substitute in 4 for y, and for x, substitute in 3. So you'll have 2 times 3 minus 2. And when you solve this, or you're not solving it, you're just doing the calculations here, 6 minus 2 will give you 4. So 4 equals 4, so that equation is correct. So that means that is a point on that line. And then we can also check with this other one. So we have 3 minus 4 plus 1 is equal to 0. Well, what's 3 minus 4? Well, that's negative 1 plus 1 is equal to 0. Negative 1 plus 1 is 0. So 0 is equal to 0. So again, I'm just checking the left and the right side. So checking left side equals the right side. Since that's true for both equations, then that solution works. All right, let's take a look at one last example. This is a word problem. So we're going to see how we can use equations of lines to model this word problem and then find the solutions to those questions. So it says at Lowell High School, the cost to attend special events depends on whether or not the student has purchased a $10 discount card. If they do have the discount card, this is going to be option A, the cost would be $5 per event. And if they don't have the discount card, so it would be option B, the cost is $7.50 per event. So we just want to find out basically what a graph of those two options would look like and what's the better deal depending on the situation. So let's determine some equations first. So we have a $10 discount card, and we have these two options. So what are we actually looking at? So what we can say is we can, first of all, just get some variables. And I'm going to say let C equal the cost, the total cost of events. That's what we're interested in. Again, we can think back to what's the independent variable, what's the dependent variable. And we're concerned about the total cost. That depends on the number of events we attend. So that would be the other variable we can take a look at. So N is going to be the number of events attended. Okay. So now, how do we make some equations? So we'll do this one at a time. Option A. Okay, so option A, we have the cost, and it says the student buys a discount card. So we know right away, before even anything happens, there's this $10 that they're going to pay. And then it says $5 per event. So we're going to be adding $5 each time there's an event. So it's going to be plus 5, and that 5 is going to, well, how many 5s are we adding on? Well, by the number of events. So we can multiply it by n. So 10 plus 5n. So that is, in a sense, equation 1. Okay, what about option B? So for option B, again, we're going to start off with the cost. This time, we have no discount card, so we don't have an initial $10 that we're paying. All we have is $7.50, so we're going to do $7.50 times the number of events we go to. And just like that, we have the equation of option B. So it's a simpler one, $7.50 times n. Okay, so let's see how we can use these to graph to make a graph of the situation. So I'm just going to write out these options down below. So A is C equal to 10 plus 5n, and B is C is equal to 750n. All right, so if we want to make a graph, well, what do we need to remember for making a graph? Let's start with A. We have a slope and we have a y-intercept. And the way we've written our equation, it is actually in slope y-intercept form. We just have to be careful. The variable is on the second part, so that just means the second number this time is our slope value, and the first number is our y-intercept. So if we're graphing this out, we start at 10, and for every 1 we go across, we go up 5. And just pay careful attention to the scale. Each grid on the scale going vertically is actually 5, so you can just simply go up basically 1 grid at a time. And I'm going to plot this out as many points as we can fit on here. Again, just trying to be as accurate as possible. Okay, let's do purple for the next one. So for purple, we only have 750n. So we only have a slope value. That means B, since it's not written there, it's just 0. So we start at 0, and then we go up 750 from there. So this one's a little trickier, just because it's not directly on like the intersection of 2 grid lines. So you go up 750 for 1. 750 plus 750 is going to be 15. Then 2250, so halfway. So you're going up 1.5 each time, essentially. Then 30, then another 1.5, another 1.5, and just continue this pattern each time you go up. All right, so let's actually graph both of those lines. I've only drawn the dots, but it's always good to have a graph of the line, actually. Let's try that one again. Okay. And you'll see I only do the arrow on the right side. We're not going to do it on the left side, and that's because, well, we can't go to a negative number of events. So we have a definitive starting point in this situation. Okay, and if we do the red line, that should look something like that. And again, going on words for there. So red is option A, and purple is option B. All right. So we want to know, when is option A cheaper and when is option B cheaper? Well, just first of all, we can kind of see that this point here, if you draw your lines nice and accurately, is the point 430. And that is the point of intersection. And in this situation, that just means at that point, they both pay the same price. So if you go to 4 events, option A or B are the same. However, if you look at the graphs, option B is growing a lot faster. And as you get further along, it's above option A. And so that means when going to more than 4 events, option A is cheaper. So A cheaper here because it's below. But as you can see early on, purple line is below. And so that means you're paying less, because that's what, in a sense, the Y value, that's representing the cost. We want lower cost, so we want it lower down. So when going to less than 4 events. And so we can say on the graph here, B is cheaper in that general region. And there we go. That's a look at a graph of those when each is cheaper. And this is also a reason why making graphs of these things and modeling with an actual equation of a line allows you to better understand the situation. All right, so that's everything for this lesson.